Okay, so with periods, before we get to the sine and cosine graph, we've got to back up and get the main things we've got first here. The very first thing is what we're going to call the periodic function. And that's basically just a function that repeats y values. Right, and the unit circle would basically be that. But the difference is what we're kind of leading up to with the sine and cosine graphs is instead of just sticking within certain x values, we're going to stretch the x values out. So we start at 0 and we go out to infinity. And then we're going to take the unit circle from just a circle graph and actually put it on like a XY axis type thing. And then that's kind of what we're going to with periodic functions here. When we talk about a cycle, that is one complete pattern. And for all intents and purposes of everything we're talking about here, we're just going to say that that's one trip around the unit circle. Okay, and again, we had sometimes where we would go around the unit circle, the unit circle more than once because we'd have like 13 pi over 2, and we just kept going around and around and around and around till we got there. So that would be one where we did more than one cycle to get to the answer that we were kind of looking for. Okay, and then the one other thing we'll talk about is the period. And a period, that's basically just your horizontal length. Which when we talk about, and again, if we take the unit circle and take it from just being a unit circle to actually putting it on an XY axis where the value is going to go through, that basically for this thing, then that's going to be the same thing as their circumference. So period is our horizontal cycle is one trip around the unit circle. The period, that's our horizontal length, which again is thinking about our circumference for this part of it. All right, the amplitude, that's your vertical length. And the way they set this up, it's always the vertical length from 0. Now, and when you kind of, for everything we're pretty much going to do, all right, we're going to keep everything based on our values. We're going to base that at 0. When you get into pre-cal, they're actually going to take, if you can think about taking our unit circle, instead of having it centered at 0, 0, that's one where they actually will take it and start moving it so that it's not centered at 0, 0. So if they don't have it centered at 0, 0, then you have to talk about what's the midline. And basically, that's the horizontal line that is halfway between the max and min. But for us, the midline will always be at 0. When you get into pre-cal, that's where it's going to change a little bit. So instead of being at 0, the midline might be at +5. It might be at -3. So think about like when we started off graphing, absolute value of x or x squared, that we always started at 0. And then once we did that, once we got comfortable at 0, then we started moving it up and down and left and right. And that's kind of what the midline is saying here is that sometimes with this thing, you're going to shift it, up or down a little bit. But for us, our midline is always going to be at 0 because we're not going to shift these graphs around. Now, I might, maybe one of those in the homework, I might give you a problem where that a graph has been shifted a little bit, and I may ask you what is the midline, and that's one where you just look at the top of the graph, you look at the bottom of the graph, and then you just figure out, all right, where would the middle of the graph then be? And just so it would be a pretty straightforward question with it. Okay, so that's kind of the background stuff we've got. Here's the big thing for the day. We're going to talk about the sine function. And you can look at it one of two different ways. And you can either say it's y equals a times the sine of b theta. And I think we looked at theta last time, which it looks like an O, but that's the Greek alphabet. That's theta. So it's just another variable instead of calling it x. Now, sometimes you actually will use x. So if they give you theta, just think about theta as being x. It's just a different way of kind of going through the mentality on these. So whenever you see theta, just realize that you can take theta out and you can think x. And actually, they'll interchange that on some of these problems. Sometimes you'll see theta, sometimes you'll see x for these. Okay. And then one small little thing with this one, when you have the sign that's here, you can think about these two things being in parentheses together. So it's not the sine of b times x, it's the sine of b times x, and you're going to take the sine of that. Or it's b times theta, and you're going to take the sine of that when you go through those parts there. Okay. Okay, and for this one, when we talk about the values here, a and b are real numbers, no imaginary numbers. So that's the great thing about this part. There should not be any imaginary numbers for everything here. Everything we're going to work with real numbers. Same thing for x and y. Those will be real number answers if we're going through this thing. Okay. When we talk about the a and the b numbers, it's here. If we do the absolute value of the a, that is the amplitude. And then the b value is your number of cycles, not your hashtag of cycles. It's the number of cycles. Twitter's forever matched that up to being a hashtag, which I guess it sort of is, but we always use it math for number of. Okay, now I'm never going to ask you for B, but the one thing I am going to ask you about when we get to these is I'm going to ask you for the period. And to get the period, that is going to be 2 pi, which is like our circumference, divided by B. So B is going to break it up into parts. You know, if we think about our unit circle, the period is, all right, how are we going to condense this period? Are we going to stretch it out? Are we going to make it longer? So we make a unit circle that's like bigger, I guess. Or are we going to condense it down and make it a little bit smaller for these things? All right, so here's your basic graph. All right, and the one thing that would be really easy that nobody should miss when it comes out of the graphs on these is that the a value that's here will be the top of the graph, and then negative a will be the bottom of the graph. Okay, and then think back to your unit circle. Just going to flash back to one real quick. We're on the unit circle. What if we're doing sine? What is the sine value at 0? Everybody remember that? Looking at your unit circle. At 0, what's our sine value? Cosine, that's sine, right? So if we start graphing this thing, if we take the unit circle we have and we start graphing this thing and put it on, instead of being in a circle, if we lay it out on like an XY axis, we're going to start at 0. All right. And then if we go through the unit circle, here we go. We're going to get to the top of the graph. That's going to be up here at 1. So when we go with 90 degrees, which is basically, if you notice on the graph on this one, we've always got it kind of split into 4. So this is like your 90 degrees. This is 180. this is 270, this is 360, or you can think pi over 2, pi, that kind of thing. Basically, the graph is going to go up till we get to the top, but instead of being 1, it's going to be the a value, because this is where, you remember when we were doing a times x squared, when we're doing the quadratic equation, how the a value told you it's kind of like the slope in this case. This one's that kind of same thing. This is going to tell you like your max and min values for this part of it. So a is going to be your max and min values. So we're going to get to the top. Once we get back to 180, we're back to 0, right? So we're going to go to the top, back to the middle. Then for sine, we're going to go to the bottom. We're going to go to the low point, -1, and then we're going to come back to 0, back over here. So this one's going to basically be the same thing. So we're basically taking the unit circle, and instead of keep going around and around and around, we're going to have it so we're now going to kind of move, so we get something like that. Okay, so just taking the unit circle, and instead of just keep going around in circles, we're saying, all right, we'll start with our sine value at 0, which is where we started with. When we got to 90 degrees, when we got a fourth of the way around the circle, we were at the top. When we got to 180, we're back to 0. When we got to 270 degrees, we were at the bottom. And then back to 0, back at the beginning, back at 360. And now this graph would keep going on and on and on forever. We're not going to worry about that part because that's where, we'll worry about more of that kind of later on. But basically that graph would just keep going and going and going and going as we go through all the parts and pieces on this one. Okay, now where all the values tie in with all the 2 pi over b stuff, that where this period is, this should be where this would end back at 0 right here. So this would be 2 pi over b. That would be the period. That's where we're going to stop for this thing. Okay, and probably the hardest part that you've got to find when it comes off a graph like this is finding these different values that's here. And finding these different values, because we're taking this graph that we've got and we're going to split it into 4 pieces, that's going to be kind of the hard part. So before I give you like just a basic idea of what that one is, let me give you an actual problem, and we'll go back and find that one, because without giving you an actual problem, sometimes that one's really hard to see. But that's the basic idea you've got for your graph that we're going to do here. All right, so here we go with an actual problem with some real numbers that we can graph this thing. So there's our problem. We're going to ask you to graph it. And then we're also going to, let's find the amplitude, and let's find out what the period is. So we're going to graph y equals 4 sine x. We're going to find the amplitude. We're going to find the period. All right, and that's where we're going to pull the information from. That's our basic function for sine. So we got to pull everything from y equals a times the sine of bx. All right, a value, really easy, right? A is equal to 4. What's our b value? What number is understood to be in front of x? Yeah, there we go. That's 1, right? Okay. So a value, easy. That's the number that's in front of sine. The b value, that's the number that's in front of x. The b value should never be 0 because, well, I guess technically it could be, but if that was the case, it would just be 4 times the sine. But if you do sine of 0, that answer is just 0, right? Because that's going back to our unit circle. If we do the sine of 0, it's 0. If it's 4 times 0, the answer is just 0. So probably in that case, you probably won't. They'll actually have a variable of some kind out here just to work through this thing, or a number or something, kind of get you going. Okay, so the parts we can get from that one, that should be pretty easy. The amplitude is the absolute value of the a value, which is that case, that's just 4. And for the period, that is 2 pi over b, which is 2 pi over 1, which in that case is great because that is just 2 pi. Okay, so if the b value is 1, when you do the 2 pi divided by b, that's not going to change anything. That just leaves it's going to be 2 pi. And so when we graph this one, there's our basics for what we're going to do. All right, so the a value is 4. So we know the top of the graph is going to be at positive 4. The bottom of the graph is going to be at negative 4. And because it's sine, we always get to start at 0, because even if you do 4 times 0, that's still going to be 0 with our a value. And then we go from there. So again, graph should always basically be this. It's always to the top, to the middle, to the bottom, and then back to the middle. So if you want some easy memorization, that's very easy memorization. That's your sine graph will always look like that. Now there's one case where it might be different, but pretty much every time we do this, that's going to be the graph that we're looking for. This number that's here, our period, which is 2 pi, that lets us know where this graph is going to stop when we've made one cycle through to get us there. Okay, so here's where we said we would kind of do this one. Here's where we've got to find these 3 values. So we need this value at the first mark, the value at the middle, the value at here, and the value we go from here. And basically from this one, to get the first value, that's the key that we're looking for. And to get the first value, you divide the period by 4. Because again, we're going to cut this thing into 4 pieces. So to figure out what that's going to be, we're going to take everything and we're going to divide that number by 4. Okay, so we're going to take 2 pi and divide it by 4. And the good thing we're going to do for you today to make the work a little bit easier is that every single one of these that we're going to do when we look at these numbers is that it should always be that this will be an even number. Because if we've got 2 pi over 4, just think that that's going to be 1 pi over 2, correct? Okay, and here's what's going to make this one really easy. As long as this simplifies down to 1 pi over 2, or if we've got pi over 2 for the first number, to get the second number, if this is 1 pi over 2, the second number is going to be 2 pi over 2. And then your third number is going to be 3 pi over 2. So the way it should kind of work for these, the first value is going to be 1. After you do the 2 pi divided by 4, whatever this fraction winds up being, it should simplify, so it's going to be 1 pi over something. So it's going to be 1 pi over something. The next one's going to be 2 pi over something. The next one's going to be 3 pi over something. And all you have to do then is simplify these numbers a little bit. So if you've got 2 pi over 2, that is just going to be pi. 3 pi over 2, it's already simplified, so we don't have anything there. So when we go back and figure out what these values are, again, we've got the first one is 1 pi over 2, or just pi over 2. The second one is 2 pi over 2, which is pi. And the third one is 3 pi over 2, which doesn't simplify. So that would put you there. And this one, if we went through counting, this would be 4 pi over 2. But again, the 4 over 2 would cancel and just give us the 2 pi. Okay, so I'm going to be nice on these problems that you get. So it's always going to be a 1, 2, 3 scenario as you go through these. When you practice these enough, when you get into pre-cal, sometimes that may not be the case. So if that's the case, then you have to do something a little bit. But in that case, really, it's easy. You multiply by 2, then you multiply by 3 to get the other two numbers, and then you go from there. So So it actually will be pretty easy. We're just practicing where everything is going to be a 1, 2, 3 scenario. All right, and again, these are distances. So when you think about these numbers, sometimes they may not give it to you in terms of like pi. I mean, that's just something for us to think about. That if you're putting this in terms of like decimal numbers, this would be, again, this is your distance, this is your length, this is about 1.5, this is about 3, this would be about, if that's 1.53, that's 4.5, that's about 6. So it's 1.53, 4.56. Again, if you think about like distance on these, if we're going through this part. All right, everybody sort of okay with that? Yeah. So again, first, second, third value should be 1, 2, 3 pi over something, and then you just got to simplify that pi over something to get it down to the next part there. All right, everybody okay? All right, ready to roll number 2? Okay, so for number 2, let's go with y equals sine of 4 theta. Okay, and we'll do the same thing we did on the last one. We'll find the amplitude, find the period, we'll graph it, do all the same things here. Again, just to make sure we're okay here, we're doing y equals a times the sine of b theta. All right, so the a value is 1, b value is 4. Okay, so again, with those two, amplitude should be pretty easy. It's just the absolute value of 1, which is just 1. Again, b by itself doesn't I'm not going to ask you for b by itself. I'm going to ask you for the period, which is 2 pi over b, which is 2 pi over 4, which is pi over 2. Okay, so top of the graph is at 1, bottom of the graph is at negative 1. Okay, and again, you should kind of already have it for this one. We're going to start at 0, because if you do sine of 0, that's still just going to be 0. So we're always going to start at 0. We're going to the top, back to the middle, to the bottom, then back to the middle. Somebody's asking, will it always be that way? For what we're doing, yes. Now, there's one time where it's not, and we'll get to that one probably on the next example that we'll look at. Okay, period is pi over 2. So we know at the end of this thing, that's going to stop us at pi over 2. And so we've got to get the first number. And so to get the first number, that is the pi over 2 over 4. And basically for these, shortcut is, if we've got something like this where it's a fraction, you can basically, and again, we can do keep it, change it, flip it. If we do that, that makes it pi over 2 times 1 over 4. So then that makes this thing be pi over 8. But again, we're going to make it kind of easy on you for this part of it. There's going to be 1 pi over 8 for the first number. Second number is going to be 2 pi over 8. Third number is going to be 3 pi over 8. So it's always going to be a 1, 2, 3 order when we go through these. So 1 pi over 8, 2 pi over 8, 3 pi over 8. But with 2 pi over 8, we can make that pi over 4. Okay, so there would be our numbers if we're going through those. Question.
Why like are we doing QTH with?
Yes. So if we did that part, it'd be pi over 2 times 1 over 4. So we get pi over 8. Yeah. So if we keep it, change it, and flip it.
Okay.
Yeah. Okay. Everybody all right there? All right. So let's give you another one here we can throw at you. All right. Let's go with y equals. Let's throw a fraction at you. Just see what happens if we throw a fraction. Sometimes y'all will freak out to get a fraction. Let's just see how it goes. So let's go y equals 1/2 times the sine of 2 theta. All right, so we've got y is equal to, and again, if we think back to the formula here, it's y equals a times the sine of b theta. So your a is 1/2, your b is 2. So the amplitude is, we need the absolute value of a half, which in that case is good. That's just a half for the amplitude. Again, period is 2 pi over b, which is 2 pi over 2, which is just pi. Okay, so the 1/2 in this case doesn't really do anything weird because that just means the top of the graph is at 1/2, the bottom of the graph is at negative 1/2. Okay, the 2 on the graph with the b with the period doesn't really change anything. That just means when we get to the end of it, it's going to be here. So we're going to start at 0, again, back to the top, to the middle, to the bottom, and then back to the middle. Okay, and this is one where it's actually kind of nice because if you get the first number, you're just going to take this pi we have here and divide it by 4. And you go, well, there's nothing really to do, right? That's just pi over 4. Yeah, so the first number is pi over 4. But again, technically it's still 1 pi over 4. Second number is going to be 2 pi over 4. Third number is going to be 3 pi over 4. And the only one we can work with a little bit is the 2 pi over 4. You can simplify and make that 1 pi over 2 or just pi over 2. So this becomes pi over 2 and this becomes 3 pi over 4. All right. Everybody okay there? Again, and this is really the hardest part of it. And if you can get to the 1, 2, 3 part on that one, it's really not bad at all because it should always be something like that you can do. All right, now here's the one problem. Here's the one example where if you get a problem that will not always look where you have the top part first and the bottom part second. So we're going to go negative 3 times the sine of 8 theta. Okay, we probably don't have to write the y equals a times the sine of b theta because I think everybody's kind of got it for now. A value is negative 3. B value is 8. So if a is negative 3, the amplitude is not negative 3. It's the absolute value of negative 3. So that means the amplitude is 3. And the period is 2 pi over 8, which means the period would be pi over 4. Okay, does anybody want to take a hint with the amplitude being, the A value being negative 3? Which way? Now, you're still going to start at 0.
We just go under first.
Yeah. So it's negative value, just like when we're doing x squared, if the A value was negative, it would go down. Same thing with this one, with A value being negative, now you're going to go down to the bottom first, and then come back to the middle, and then you'll go to the top, and then back to the middle. So the A value just tells you which way to go. If the A value is negative, that means you got to go down first. If the A value is positive, you got to go up first. So it's still directional, just like when we did x squared and absolute value of x, all those other graphs. That the A value still tells you which way to go for this thing. The period here is pi over 4. All right, so our first number is going to be pi over 4 divided by 4. But we said shortcut for that one is just go ahead and multiply these two numbers together. So the first number is going to be pi over 16. All right, second number. That's 1 pi over 16. Second number is 2 pi over 16. Third number is 3 pi over 16. But again, with the 2 pi over 16, we can simplify that and want to make it pi over 8. So first number is 1 pi over 16. Second number is 2 pi over 16 or pi over 8. Third number is 3 pi over 16, and that one will simplify. So then that should be what we're looking for there. Okay, so there's your sine graph. We'll show you cosine graph because cosine graph is almost the exact same thing. The only thing that's different about a cosine graph is that it's the exact same graph. It just looks different because we're only getting one little cut of this one. The biggest difference is when we do cosine, it just doesn't start at 0. And we only need like 1 or 2 examples on this one, then we'll be good. Okay, so for cosine, same thing we did with sine. It's either a times the cosine of b theta or a times the cosine of bx. And again, whether they throw in theta or x, it's the exact same graph. And here's the big difference for these. Okay, and this is the big difference. Cosine graphs, they will start at the a value, and then they move from there. And then sine graphs, again, always start at 0. And if we didn't put that back here, you may want to go back and put that back here on that very first page, way back here when we first did this thing, way back in the beginning for sine. You may want to go back here and just put the, sine graph starts at 0. So your sine graph always starts at 0 Cosine graphs will start at the a value. So that's the big difference of the two. So cosine graphs always look something, or sine graphs always look something like this, whether it's top this way or bottom this way. Cosine graphs, it's again, we're only taking one little snapshot. If we stretch this snapshot out, it look exactly the same. But as we go through these, it's going to look just a little bit different because of us starting at the a value and not starting at 0. Okay, so the amplitude is still the same thing. It's still the absolute value of a. The period, it's still the 2 pi over b. So all those values are the exact same thing on this one. So that part, there's nothing really that you have to worry about. When you graph these, basically we've got 2 graphs. Okay, if your a value is positive, so if the amplitude is still a and negative a, right? And we're going to start at the a value. So if the a value is positive, you're going to start at the top, right? Okay, if you're starting at the top, where's the only way to go? Got to go down, right? And the way you do this one, you cannot go just straight to the bottom. Before you get to the bottom, you've got to go back to the middle. Then you get to the bottom. And once you're at the bottom, there's only one way to go, right? Then you got to head back up. Before you can get to the top, you got to get to the middle. And then you get back to the top. So if the a value is positive, it always looks like a bowl of some kind. And if your a value is negative, again, with cosine, you always start at the bottom. So for that one, if a is negative, you're going to start at the negative value here. You're going to start at the bottom. Then you're going to get back to the middle, and then to the top, back to middle, and back. And again, it's not a straight line because it's a curve as we go through these. So it's one of those where you're going to curve in, do something like this, curve up, come back to the middle, and then back to the bottom. So if the a value positive looks like a bowl, a value negative looks kind of like a mountain. Now, and again, the catch on this one is that we're only taking one little snapshot. That if we kept going on this thing, it would keep going out this way and would still keep repeating and still keep repeating. Same thing here. This one would just keep repeating and repeating and doing that. So if we were to graph that and compare that to our sine graph, they look exactly the same. The only difference is, again, one's going to start at 0 and one's going to start at the top, or one's going to start at the bottom, but it's got the same pattern. It just, they're going to start at different places as you go through this. All right, so let's graph like 1 or 2 of these, and then we'll be done. Everybody good there with that part before we move on? Yep, okay. Okay, so let's go with y equals 4 times the cosine of, I'll throw you a good one right off the bat here, cosine of 1/2 x. Throw another fraction at you. Okay, so a value is 4. B value is 1/2, easy to find. Amplitude, we know it's the absolute value of that. We know the amplitude is going to be 4. And for the period, that's going to be 2 pi over 1/2. And you're going, I don't like the fraction there. But remember, we're going to keep it, change it, flip it, right? Keep it, change it, flip it. So if we do keep, change, flip on this thing, it's really 2 pi times 2 over 1. So 2 pi times 2 means the period is actually just 4 pi. And when we graph that, you'll actually like that because you'll see it here in a second. It's actually really good that it comes out to be 4 pi. Is that okay where we got the 4 pi there? All right, we'll do the same way we did with the sine graph. We'll get 4 key values we're looking at. Top of the graph is 4, bottom of the graph is -4. Again, the big difference with cosine is whatever the a value is, that's where we start. So if we start at the top, before you get to the bottom, if you start at the top of the building, you got to go through the middle to get to the bottom. So we're going from there to the middle, back to the bottom. And if you're going to work your way back to the top, we're going back through the middle and then back to the top. So there's our bowl or graph we have there. Okay. Period is 4 pi. And here's where it works out where the period is actually kind of nice with that one. Because what happens when you take 4 pi and divide it by 4? Yeah, it works out great. It's just 4 pi divided, that's just pi. So the first number is 1 pi. Second number is 2 pi. Third number is 3 pi. There you go. So in that case, it actually works out really nice with the b value being a half, because once the last number is 4 pi, when you divide it by 4 to get the first number, it's just already just 1 pi. So it's just 1 pi, 2 pi, 3 pi, 4 pi when you go through the steps there. All right, one more graph with a positive number, and then we'll be done.
Wouldn't it be 2 pi over 4 though? Did you have to divide by 4?
Well, if you go back to because it was, for the period, it was 2 pi over b. So if we do the keep, change, flip, it's 2 pi times 2, which means the last number is 4 pi. So if the b value was 1, it'd be 2 pi, and we would divide it by 4. But because it's 2 pi over half, we got to do the keep, change, flip to figure out what this period number is. So the last number is 4 pi. And if we cut it into 4 parts, that's where we get the 4 pi divided by 4 to get just the pi there. So I think you're thinking back to back to that one where, like, if we were doing the period was 2 pi over 1, and that made it 2 pi, and then we took the 2 pi divided by 4 to make it pi over 2. So in this case, it worked out kind of nice because the last number was just 4 pi. After we did the 2 pi over b, it gave us that the last number was 4 pi, and then we got to split it nice and easy from there. All right, one more, then we're done. All right, so for this one, let's do a -8. So that one was a positive number. Let's give you a negative number. Let's do -8 times the cosine of, this will be fun, 2 pi theta. Okay, so we know the a value is -8. The b value in this case is not just 2, but it's 2 pi. So the amplitude of -8, the absolute value of -8 is just 8. And for the period, it is 2 pi over b, which is 2 pi over 2 pi. So the period in that case is just 1. So when we do the numbers on these, they're not going to have any pi numbers in it. It's just going to be a straight number with, 1s and 2s and 3s and 4s and that kind of thing. All right, amplitude is 8. Okay, we've got our period is 1. And it's actually not going to be bad because what happens when we take 1 and divide it by 4? Yeah, everything's in quarters, right? So now we got 1/4, The next number would be 2/4, but we can simplify and make that 1/2. The next number would be 3/4. And they might actually put decimal numbers. They may put 0.25, may put 0.5, they might put 0.75. So they may throw out the fractions. They may also throw some decimals at you there. Okay, and for cosine, again, big differences for cosine. You start at the a value. So this one, we're going to start at -8. And if you're riding an elevator, before you can get to the top, you got to go back through the middle floors before you get to the top. And once you get to the top, if you're going back to where you parked your car in the parking deck below the basement, then you're back to there. Okay. Took a little bit longer than I thought, but anyway, we got it done. Okay, so again, big takeaway. Sine starts at 0, cosine starts at whatever the a value is, and then the graph should just kind of go from there based on what number